This decimal, and it's a repeated decimal, and the way we know it's repeated is it has the line over top of it. That lets me know it's repeating, that whatever numbers the line is over are repeating. So in this case, it's just 3 over and over and over again. Here it's 4, 5, 4, 5, 4, 5, 4, 5. This one is 621, 621, 621, 621. This one goes 5, 4, 9, 4, 9, 4, 9, 4, 9, 4, 9, because only the 4, 9 are repeating. So what we do is we count the total number of decimal places. Okay, so we're going to count the total number of the decimal places, and this is how many 9s are going to be in the denominator. Now when you had the non-repeating, that was how many 0s we were going to have in the denominator. But now that we're repeating, that's how many 9s. So I have 1 decimal place, so that's going to be 1 9 in the denominator, and I'm going to put the 3 over top, and then I'm going to reduce. Okay, so 3 and 9 both divide by 3. And that's going to give me 1/3. And if you want, we can check it. If I say 1 divided by 3, which is 1/3, I get 3's forever. Okay. 45 has a bar over it, so there's 2 decimal places, so 2 9s. And these will both divide by 9. And that's going to give me 5/11. Again, if I want to check it, 45's forever. Okay. 3 decimal places, 3 9s. Right, I'm going to check to see what I can reduce this by. If I add 6 and 2 and 1, that makes 9, and obviously 9s are divisible by 9, so I can divide both of these by 9. Okay, so I'm going to get 69 over 111. If I add up 1, 1, and 1, that's 3. And then 69 also will divide by 3, so I can divide this again. And I get 23 over 37. Okay. Now don't let the fact that only 2 numbers are repeating mess you up. Yes, only 2 numbers are repeating, but I still have 3 decimal places. So I'm still going to do 3 9s. Okay, so even if only 1 number was repeating and I had, 5 decimal places, I'm still going to do it over 5 9s. It's not about how many are repeating, it's about how many decimal places are all together. These will both divide by 9. And I'm going to get 61 over 111, and then 61 is prime, so there won't be anything that these divide by. We're going to do all of the perfect squares up to 20, etc. Remembering that if I square something, so for example 2 squared, oh that's a bad example. So 3 squared is not 3 times 3, 2, it's 3 times 3. Okay, squares. Right. So that tells me The square root of 361 is 19. So they go backwards. Square root of 900 is 30. So if I look at these, all I have to do is look down this list on the perfect square side, and then I know what the square root is. Well, if we know that 2 squared is 4, then the square root of 4 is 2. If I know that 5 squared is 25, then the square root of 25 is 5. Okay. 100, well, where is it? 10 squared is 100, so that's 10. 625 and 196. 14. A fraction inside of a square root is the same thing. Yours is over 121, right? Okay, we'll fix it. This is the same thing as the square root of 25 over the square root of 121. So if these are both perfect squares, you can split it. And what you do is you take the square root of the top, square root of the bottom. Now you don't have to write this step in if you don't want to. If you look at this, 36 is a perfect square, 100 is a perfect square. So I'm going to take the square root of 36. I'm going to take the square root of 100. Of course, now I'm not done because this fraction can be reduced. So I'm going to divide both of these by 2. And I'm going to get 3/5. Now, because these were already perfect squares, I don't want to reduce them ahead of time, because if I had reduced these each by 2, I would have gotten 18 over 50. And then I would have gotten, actually no, that still would have worked, 9 over 25. It won't always work. In this case it would have worked. But you want to, if they're perfect squares, take the square root first and then do any reduction. Now sometimes you might want to reduce, so let's say I have okay, 50 over 72, these are not perfect squares, right? But they're both even, so I'm going to divide them by 2. And I'm going to get the square root of 25 over 36. So if I have numbers in here that aren't perfect squares, see if you can reduce the fraction to get perfect squares. And now that I have perfect squares, I can take the square root. Does that make sense? Okay. These are not perfect squares, but we can estimate. An estimation is an approximation, right? Okay. Here's what we're going to do. We're going to take the square root of 19. Okay, that is not a perfect square. But 19 is between 16 and 25, which are perfect squares. So like we go back to this, 16 and 25, 19 falls in here, right? The square root of 16 and the square root of 25 I can take. Is 19 closer to 16 or to 25? It's closer to 16, right? So it's closer to 16. So I'm going to take the square root of 19 and say it is approximately 4, because the square root of 16 is 4. and 19 is close to 16. And this little squiggle equal right here, that's what that means, approximation. Now you couldn't say the square root of 19 is equal to 4 because it's not.
So you have to put the little squiggle.
You have to put the squiggle equal. That means that's an approximate, so it's approximately 4. And if you want, we can check it. 19, I take the square root, it's 4.35. So it's approximately, yeah, so it's approximately 4. We do the same thing for 38. 38 is between what two perfect squares?
What?
38.
It's between 38 and 27? Oh.
It's between which two perfect squares?
Oh.
36? 38. So it's between 36 and 42, right? Or sorry, 49. Which one's it closer to? 36, right? So since it's closer to 36, the square root of 38 is going to be close to the square root of 36. So the square root of 38 is approximately 6. Okay, so square root of 27, what's 27 close to?
It's closer to...
It's close to 25, right? So this is approximately 5. Oops. What is, look on your perfect square list, what is 85 close to? Okay, so what's the square root close to? 9. And how about 628, what's that close to?
Yeah.
It's close to 625. So it's approximately 25. So that's all you need to do. You need to, if you get like this where it says to estimate the square root, you look at, well, what is the perfect square that this number is close to? And then take the square root of that perfect square and put the squiggle in it. Does that make sense? Is if you have the same sign, if they match, you're going to add them together. And you're going to keep the sign the same. Okay. Now, if you have two positives, you guys are really familiar with that. 2 plus 5 is 7. That's not a problem. It gets confusing when you throw the negatives in there. So if I have a -3 and a -6, so I have -3 plus -6, they match, not with the adding. Okay, they match, so I'm going to combine them. So 3 and 6 is 9, because they're both negative, so is the 9. If it helps, this is money I've borrowed from you. I borrowed $3 from you, and then I borrowed another $6 from you, so now I owe you $9, right?
If it's two negatives and there's a minus sign in it?
We'll get to that in a sec. Yeah. Okay, these are all positive. This should, this shouldn't give you any trouble. 6 plus 6 is 12, plus 3 is 15. Here I have 3 negatives, all negatives, so I'm going to add them together. So -5 plus -3 is -8, plus -9 is -17. So 5 plus 3 plus 9. And then keep it negative because they're all negative. So in this instance, I borrowed $5 from you, and then I borrowed $3 more from you, and then I borrowed $9 from you, so now I owe you 17 bucks. Except not really. Oh, just fix it, it's a plus. Sorry, it didn't print very well. Okay. The rule for different signs is that you subtract the number. So if they don't match, you subtract the numbers. And you keep the sign Yeah, of the biggest or highest. It's not the greatest though, because a positive is always greater than a negative. But I say biggest because 6 is bigger than 2, even though negative 6 is less than positive 2. So here I have a negative and a positive, so I'm going to subtract. So 6 minus 2 is 4. The 6 is bigger, so my answer is going to be negative 4. Bless you.
Thank you.
Here I have a 10 plus negative 4. So this is the same thing as 10 minus 4, really. But I'm going to subtract 10 minus 4, and because the 10 is larger, my answer is positive. Here I have mixed up. I have 2 negatives and then I have a positive. So first I'm going to combine these together because they're the same sign. So I have a negative 4 plus a negative 12. That gives me negative 16. And then negative 16 plus 13, so that's opposite signs. So I'm going to do 16 minus 13, that's 3. And the 16 is bigger, so it's negative. Here, negative 15 and positive 12. 15 minus 12 is 3, and 15 is larger, so it's negative. So in order to convert from subtraction to addition, you're going to do what's called adding the opposite. Okay, so we're going to convert all of these first. So I have negative 4 minus 8. That's the same thing as negative 4 plus negative 8. 9 minus 15 is the same thing as 9 plus negative 15. Here, this I want to show you guys. This is my own invention. If I have minus a negative, so minus a negative whatever, it doesn't matter. Doesn't he look happy? And isn't that a positive thing? Right? So if I have minus a negative, look, he's happy. So it's positive. 2 negatives make a positive. So minus negative is plus. The other way that you can do it is see how this is minus a negative, and if I connect the dots, it looks like a big plus. So I get 5 plus 9. Did you find it? Okay. And then negative 10 minus 13, the first sign doesn't change or anything like that. I just add a negative. Okay, so those are all converted now. Once they're converted, then we can add them. I have 2 negatives, so 4 and 8 is 12, negative 12, because we're still adding. Yeah. 9 and 15, negative 15, so I've got opposite signs, so I'm going to subtract. Here I have opposite signs, so I'm going to subtract, and the 12 is bigger, so my answer is positive. These are the same signs, so I just add. These are the same signs, so I add, but they're both negative, so my answer is negative. Oh, sorry. If the signs match, that means you win, and that's a positive thing. So when you have matching signs, the same signs, your answer is positive. Okay. If you have different signs, they don't match. And that means you're sad because you didn't win. And that means it's negative. Okay. So, 2 positives, that's easy. You guys have that down. You've been doing that forever. Okay, 2 negatives. Because I'm multiplying, 2 negatives make a positive. 2 positives, no problem. 2 negatives make a positive. Here I have 2 negatives, that gives me a positive, divided by a positive, which gives me a positive. Okay. Here I have signs that don't match. I have 1 negative, 1 positive, so my answers are going to be negative. Positive and negative gives me negative. Negative and positive gives me negative. Negative and positive gives me negative. Here I have negative and positive, so that gives me negative, divided by a negative, which brings me back to a positive. because those ended up being the same. Now, here's a tip. Okay. You know how sometimes you get problems where you have 3 or 4 or 5 numbers to multiply in a row all together? Count the negatives. Okay. If you have an even number of negatives, your answer is positive. If you have an odd number of negatives, your answer will be negative. So just as an example, okay, if I asked you to multiply all this together, what you can do is you can say, okay, there are 1, 2, 3, 4, 5 negatives. So my answer is going to be negative. Once you know that, once you know which sign your answer is going to be, then you can ignore all those negatives. And you can just concentrate on multiplying 2 times 3 times 1 times 5 times 6 times 2 times 7 times 8. And then whatever number you get, just put a negative in front of it. It just saves you having to deal with all the negatives throughout the whole thing as you're going. It's a time saver. Okay, the definition of perimeter is the distance around the outside or the outer edge of an object. Okay. All right. So if you're going to calculate perimeter, you can use formulas, or you can simply add all the sides. So you have a choice. Okay. The formula for a rectangle, perimeter equals 2L plus 2W. Or you can just add up all the sides. Same for parallelogram. 2L plus 2W. A square, if the sides are S, the perimeter is equal to 4S, because all the sides are the same. Well, there's really not a set formula for a triangle. You just have to add up the sides. Find the perimeters of these. Before we start, if this is 8 centimeters, this side is also, yeah. And this side over here would be 5 centimeters. So if you wanted to add up all the sides, you'd go 5 plus 8 plus 5 plus 8. Same here.
Would you add up all of them?
No, area you multiply. We're going to do area Friday. So, but with perimeter, you're going to add, you add all the sides. So you're adding, it's the distance around the whole outside. So you'd add up all the sides here. Or we can use the formula, which for these two is 2L plus 2W, right? So you can do 2 times 8 plus 2 times 5, which gives me 16 plus 10. So it's going to be 26 centimeters. Okay, same for rectangle. I can do 2 times the length plus 2 times the width. So I'm going to get 6 plus 4, so that's going to give me 10 inches. Okay, the formula for square is a little different. It's 4S. Well, my side is 1 foot, so I'm going to have to multiply this problem, and it's a very difficult multiplication, and I'm not sure if I know this one. Okay, 4 times 1. Anybody help me out? 4 times 1.
4, yeah.
So that's 4 feet. Right, because in a square, all the sides are the same length. And then for the triangle, I just have to add. So 3 plus 4 plus 5. So it's going to be 12 millimeters. Perimeter of a circle has a special name. It's called circumference. But it's still the same thing. It's still a perimeter. It's the perimeter of a circle, and it's the distance around the outside. Okay, and I know you guys have distances on here too, so hold on one second. Let me get. Okay, so the formulas for circumference, there are two formulas. You can either do 2 pi r, which is probably the one you're most familiar with, 2 pi r, or you can use pi d, because 2 times r gives you d, right? Because the radius is half of the diameter. This diameter is how much? I think it's 12, right? And this one's
3 centimeters.
See, it looks like Pac-Man, but he's not eating right now. Okay. So for my circumference on this one, oh, and pi, we're going to use 3.14. And have you guys all seen the thing where if you use this 4 and then you flip it around, whoops. I didn't do my 3 backwards. Pi says pi. Right? If I flip it backwards like a mirror image, 4, 1, 3, but backwards, it says pi. Pi says pi. Yeah. Just a little silly something I saw on the internet. Anyway, so pi we're going to use 3.14 always. Okay, pi is obviously much longer than that. Pi goes on forever. It never ends. So for our purposes, that would be a ridiculous number to try to use to multiply by. So we average it out, or we take an estimation of it, or a rounded. So if we have the diameter, then you use pi d. So that's 3.14 times the diameter, which is 12. So it's 37.68 inches. Okay. If you have the radius, then you use 2 pi r. All right. So if I have a positive times a negative, what's my answer going to be? Negative. So then I just multiply the decimals. I can ignore the sign after that. So 7.2 times 0.02, so 0.144, and I know it's negative because I have a negative and a positive. Same here, a negative and a positive, my answer is going to be negative. So 0.027. Here I have 2 negatives, so my answer is going to be positive. Okay. Same with division. Oh, I want you to change one of these. Make this one positive, just because they're both negative. So I have 2 negatives, so my answer is going to be positive. Here I have 1 positive, 1 negative, so my answer is going to be negative. Okay. Okay, so multiplying fractions. Okay, you multiply across and then reduce, Or you can cross cancel, then multiply. Okay, so I'm going to do both. If I have 1/2 times 3/5, I just multiply straight across. 1 times 3, 2 times 5. That gives me 3/10. Okay, these were both positive, so my answer is positive. They follow the same rules also. Okay, so it follows the same sign rules. So if I had negative 2/3 times positive 6/7. Okay. I'm just going to give me a negative because I have a negative times a positive. Multiplying straight across, I get 12 over 21. 12 and 21, that's reducible. So I get negative 4 over 7. Okay, so this was multiplying and then reducing. Or I'm going to take the same problem, and instead of multiplying first and then reducing, I'm going to see if I can cross cancel, which is reducing first and then multiplying. So I look at the 2 and the 7. 2 and 7 don't have anything in common, but 3 and 6 do. 3 and 6 will both divide by 3. So 3 divided by 3 is 1. 6 divided by 3 is 2. Okay, so I'm dividing by 3 here for these. Okay, then if I multiply, I have a negative times a positive still. 2 times 2 is 4. 1 times 7 is 7. As you can see, I got the same answer. It's just in one example, we multiply and then we reduce. In the other example, we reduce and then we multiply. Let's do one more. If I do 3/10 times 15/21. 3 and 21, I can cancel there.
7. Oh, there's the 7.
And then the 15 and 10? Yeah, they both divide by 5, so I get 3 and 2. And so then if I multiply, I get 1 over, or not 1, sorry, 3, 1 times 3, and then 2 times 7, so 3 over 14. And if you think about this, if I had multiplied this straight across, I would have had 45 over 210. So you would have had some reducing to do, and those numbers are not necessarily as easy to reduce as 15 and 10. So it's useful to cross cancel first. Important thing here, ready? You cannot multiply mixed numbers. No. Okay. You have to convert them into an improper fraction in order to multiply. Okay. I have seen people do the multiply the fraction parts and then multiply the whole number parts and then tell me that's the answer. No, 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 no. No. And there are no steps for multiplying mixed numbers. It doesn't, that mathematical operation, it does not exist. You have to make them improper fractions. They have to be fractions in order to multiply them. So, converting a mixed number to a fraction. Let's say I want to multiply negative 2 and 1/3 times positive 4 and a half. Okay. To convert these, I take 2 times 3 plus 1. And then 4 times 2 plus 1. So 3 times 2 is 6, plus 1 is 7. So this becomes negative 7/3. The sign never changes when you convert. And then 2 times 4 is 8, plus 1 is 9. So that's times 9 halves. Now I can multiply. This I can multiply, this I cannot. So I'm going to look at this. I can cross cancel here. 7 times 3 is 21. 1 times 2 is 2, and it's negative because I had a negative times a positive. Okay.
So that's
Reciprocals are just flipped numbers. Okay, so if I have a fraction and I take the reciprocal, I just flip it over. So 2/3 and 3/2 are reciprocals of each other. If I have a whole number, it's flipped as well, 1/5. These are reciprocals of each other. And if I have something like 1/2, the reciprocal of 1/2 is 2. So they're just flipped. Now when you're dividing fractions, the technical term for what you're doing to divide fractions is multiplying by the reciprocal. But I never say that. The way I like to say it and the way I learned it was copy dot flip, because this is actually like directions for what you do in the step. You copy the first thing, then you dot, and then you flip the second one. You may have heard, what is it, KCF instead of KFC, keep, change, flip. Have you guys heard that one? Keep, change, flip. Yeah. So this is keep, change, flip. I like copy dot flip. It's whatever makes you remember it. It doesn't matter. So if I take, again, dividing fractions follows the same sign rules. So 2 negatives make a positive and a negative make a negative. So if I take, say negative 2/3, and I want to divide it by negative 1/4. Okay. See how here I have a 2 and a 4, and you might think, ooh, I can cross cancel. You don't cross cancel on the division. You can only cross cancel on the multiplication. Okay, so what I'm going to do is I'm going to copy, I'm going to dot, and then I'm going to flip. Now I have multiplication. And then I multiply. I have a negative times a negative, so it's positive. 2 times 4 is 8. 3 times 1 is 3. If I have okay, I've been positive divided by negative, so my answer is going to be negative, but I'm going to copy, I'm going to dot, and I'm going to flip, and now I can cross cancel. After I've turned it into multiplication, then there's a chance to cross cancel. 1 times 3 is 3, 7 times 2 is 14, and I have a positive times a negative, so it's negative. Oh, and speaking of negative, in fractions, negative placement. It's okay to put the negative up front like this, so, or up top, so I can say negative 3/14, or it's okay to put the negative like directly in front. What you never do is put the negative downstairs. That's not proper form. So we don't do that. It either goes up top or out in front. Okay. Mixed numbers is the same rule. So you're going to convert them to improper. Then, you know, divide or then divide. Does anybody want to see one of those? Okay. Give me a mixed number, any mixed number.
12
Did you say 12 over 5?
Yeah.
Okay, well let's turn that into 1 and
2 over 5.
2. Sorry, hold on. You said 12 over 5, so that's going to be 2 and 2/5. And we're going to divide that by what? Just a plain old 2?
2 over 1.
No, we can do it by 2. That works. Okay, if we can't deal with this. This is fine, but this we can't deal with. So we're going to convert that by multiplying and then adding. And this is going to give me 12/5, like you had originally said, divided by 2. And then I'm going to copy, I'm going to dot, and I'm going to flip. And when I flip a whole number, I put 1 over top of it. And I can cross cancel these. So 6 times 1 is 6, and 5 times 1 is 5.